Hello everyone, here we are back to the essence of regression, talking about multiple regression. So today we're going to take a journey into regression in kind of a way where we're just going to take in certain variables that are essential to regression and certain core values associated with these essential variables and what they tell us about multiple regression. So what you're going to notice here is that I'm going to, in a very quick way, I really think of myself as like one of the fastest putter-uppers of like data set illustrations, like in the world. Okay, so don't feel you have to fast forward it ahead or anything like that, because bam, man, are you ever going to see me do this quick? Okay, so here I go, and we'll go ahead and put this data set up here, just in terms of an illustration of it, and we'll take things from there. Oh my God. That is tiring going through that as fast as I did. But anyway, I did it. So I'm going to shake it off now a little bit. Whew. Oh, that was quick. But anyway, so now it's all done, and I got it all up here for you. And what I want you to do, and you're going to do this along with me, I first of all want you to just take it in here, what we have, okay? So I'm going to go ahead and I'm going to describe to you what we have, and you can just follow along here, because there's a lot to learn from what's up here, but we have to take a moment to take it in and come to appreciate it. Okay, so way over here we have in our rows our participants. So these are the participants in our sample for our multiple regression analysis. And I have down the first 5 participants: participant 1, participant 2, participant 3, participant 4, participant 5, all the way to participant 100. And by the way, I didn't just randomly choose 100 participants for this sample. If you do a power analysis on this with 2 predictor variables in the model, actually with 100 participants you're overpowered. I guess there's no such thing as being overpowered, but you got plenty of statistical power to find significant results if there are genuine effects in the population. So we're all set with the idea of 100 people in this sample, or 100 participants in this sample. Okay, so that's what's in the rows, is our participants in our sample that we're doing our multiple regression analysis on. And we have 100 participants in our sample. And then in our columns, we have certain essential variables for understanding multiple regression, and associated with some of those essential variables are certain core values, what I call the 3 core values of regression. And so let's talk about these essential variables, and for some of them, their associated core values. Okay, well, when you look at this data set, and you look at the particular variables that we have up here, the first thing you notice is that we have a multiple regression situation here where we are developing a model, and we're seeking to develop a good fitting model. That is our goal, of developing a good fitting model. Now that's an important thing to keep in mind, that we're developing a model here. And how do you know? How do you know that we're in the stage of developing a model here? By looking at these variables. You know that because, look, for each one of our participants, we have 2 values on the outcome variable. And in fact, here, let me change something right here. See, I was going so fast, I didn't do this exactly right, so let's make it right. There we go. Outcome variable, okay? So you know that you are at the stage of multiple regression here where we are developing a multiple regression model and seeking to develop a good fitting multiple regression model. When you see that we have, for each one of our participants in our sample, we have two values for the outcome variable. Okay, so for each participant in our sample, you'll notice that we have an actual observed value on the outcome variable being organizational commitment, and we have a predicted value on the outcome variable, organizational commitment. Put a colon there for us. So that's what we have for each participant. So here we have participant 1. We have an actual observed value in the outcome variable, and this is the value we get from participant 1 when we actually give participant 1 a measure of organizational commitment. And we actually give each of the participants a set of measures. We give them a measure for the outcome variable and a measure for each of the predictor variables. Here are our predictor variables, by the way, in the model. But let's get back to our outcome variable. We give each of the participants in our sample a measure of the outcome variable, and we get those measures back, and we score them, and we get an actual observed value on the outcome variable. And so we have that for each of our participants. Now, that actual observed value in the outcome variable is really important. It's really important when we're developing a multiple regression model. Because ultimately, when we're developing a multiple regression model and seeking to develop a good fitting model, is we have to see how well does our model, with the information contained in the model for each of our participants. In this case, the information contained in the model for each of our participants is job satisfaction information and each participant's perception of how positive their work setting is. Okay, so that's the information that we have in the model on each of our participants as represented by the predictor variables in the model. And ultimately, we're interested in how well does the model, based on the information that we have for our participants in the model, predict their scores on the outcome variable. Well, if we're going to develop a model and know how well the model predicts scores on the outcome variable, we have to have some standard against which we can compare the predicted values coming out of the model on the outcome variable for each of our participants. If all we have are the predicted values, well, who knows how accurate those predictions are? We have to have some standard against which to compare those predicted values coming out of the model, and that's standard. And what better standard than the actual observed values for each of our participants on the outcome variable? So if you're given a data set and you have certain variables in the data set and you're asking yourself, you're asking yourself like this. When you scratch your head, you probably come across some hair when you scratch your forehead. Not me, not anymore. You may ask yourself, is this model, this multiple regression analysis, is it seeking to develop a model? Well, if you see two values for each participant in your sample, if you see two values on the outcome variable, you know that you are in the stage of multiple regression where you are seeking to develop a model, a good fitting model. Because you have the predicted values on the outcome variable coming out of the model based on the information in the model that we have for each of our participants. And then you have the standard against which those predicted values are compared. Because again, without a standard, you don't know how good the predictions are. Well, we got our standard that we can compare those predicted values to. We have the actual observed values on the outcome variable, along with the predicted values coming out of the model. And so now we can see, well, how close overall, across all 100 participants in this sample are the predicted values coming out of the model based on the information that we have for our participants in the model, represented by our predictor variables, coming to the actual observed values on the outcome variable, their actual scores. When they actually took the measure on the outcome variable and we scored it, and we have our actual scores for the 100 participants, their actual observed values on the outcome variable, we'll compare the predicted values out of the model to their actual observed values on the outcome variable. And if overall those predicted values are coming close to the actual observed values on the outcome variable, then we say we have a good fitting model. That is, the predicted values coming out of the model fit well with the actual observed values on the outcome variable. So our model, as represented by our predicted values, fits with the data well, the data being the actual observed values on the outcome variable. That would be what we mean when we say we have a good fitting model, or a model that fits well with the data. Now, that brings us then to the residual value, and our third core value. So here are three core values of regression, these values being associated with essential variables in regression. And that is the actual observed value on the outcome variable, the predicted value coming out of the model on the outcome variable, and the residual value. And what the residual value is, just said more informally, it is the error in prediction. The error in prediction, or how far that predicted value coming out of the model is from person's actual observed scores on the outcome variable. And so you tell me, you're there, you're watching this video. We'll engage a little thought experiment here. You tell me if these residual values across our 100 participants. Now, we're not concerned about what the residual values are for any particular participant when it comes to determining model fit. We're concerned with how well the predicted values, how close they're coming to the actual observed values on the outcome variable across all 100 of our participants. So we're concerned with our residuals or our errors in prediction across all 100 participants in our sample. So you tell me, if looking across all 100 participants in the sample, those residual values, those error in prediction values, are low. So there is overall, not in every single case with every single participant, but overall, the predicted values coming out of the model are coming pretty close to the actual observed values on the outcome variable across our 100 participants in the sample. Would we have a good fitting model or a poor fitting model? Da 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 da. You're correct. We would have a good fitting model because overall, with those low residual values or low error in prediction values, those predicted values coming out of the model are coming close to the actual observed values on the outcome variable. And so that's telling us that our model, containing information for our participants on their job satisfaction and their perceptions of the positiveness of the work setting, is doing a good job in its predictions coming out of that model at predicting persons' actual observed values on the outcome variable. And that then is a model that is fitting well with the data or the actual observed values on the outcome variable. Okay, now you tell me, kind of obvious because there's only one choice left. We either have good fitting models or poor fitting models. We actually have models that fall in between. You can have a moderately good fitting model. But let's think about it in terms of a good fitting model, which we just described, and a poor fitting model. What would you expect those residual values to be then across our 100 participants in terms of how far off the predicted value coming out of the model is from persons' actual observed values on the outcome variable? So give that some thought. So da 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 da. I won't do the Jeopardy theme now. Da 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 da. Okay. Well, you know the residual values. If we had a poor fit, in the model with the data, so that the predictions coming out of the model, we're not doing a good job at predicting people's actual observed values on the outcome variable, these residual values would be high, right? They would be large, okay? Overall, across our 100 participants, the residual values would be large, meaning we're having high errors in prediction, or the predicted values coming out of the model are a good distance away from the actual observed values on the outcome variable. And here we have a model then that's a poor fit with the data. It just isn't telling us much. Knowing our participants' job satisfaction and their perceptions of the positiveness of the work setting, it just doesn't tell us much having that information in the model on our participants as to what their scores are on the outcome variable, or in other words, as to what their level of organizational commitment is in this example. So in that case, the information in the model really isn't of much use for us in predicting the scores on the outcome variable. So there we'd have a poor fitting model. Okay, so that is what is happening here, okay, in terms of developing a good fitting model. We want to put predictive variables in the model which provide us with information on our participants that do a good job at predicting person's actual observed values on the outcome variable, in this case organizational commitment. And those predictions are represented by our predicted values on the outcome variable. You'll have a series of predicted values right along with a series of the actual observed values. So if the actual observed value on a scale of 1 to 10 for organizational commitment, 1 being low organizational commitment, 10 being high organizational commitment. If a participant 1, it was a 7. But the predicted value out of the model on the outcome variable was 5. Then your residual value is 2. The predicted value is 2 units away from the actual observed value. And that would continue for each of our participants. And we're looking for a good fitting model where those residuals are low across all our 100 participants, so that with the information we have in the model for our participants, we're doing a good job with our predicted values at predicting actual observed values on the outcome variable. And that says, if we do get that good fitting model, that knowing about person's job satisfaction and their perceptions of the positiveness of the work setting, it tells us a lot, in the case of a good fitting model, about what their level of organizational commitment is. So that's what we're seeking to develop, our good fitting models. Now, let me tell you something else here about developing a model. Because there's actually 2 purposes for multiple regression in terms of the model that you develop. And that is, you either want to use the multiple regression model for explanation purposes. So if we were using it for explanation purposes and we had a good fitting model here, we could say that if you know about person's job satisfaction and their perceptions of positiveness of the work setting, that has a lot to do with understanding, with being able to explain person's organizational commitment. That would be valuable information just to know what contributes to people's organizational commitment. If you were seeking to have the model serve that explanation purpose, you'd want to do things. If you were interested in having people have higher levels of organizational commitment in your organization, you'd want to find ways to increase job satisfaction, to have a positive work setting, because you would know then at that point that that contributes to higher levels of organizational commitment. But again, you have to develop that good fitting model before you can use it for explanation purposes. The other reason we use multiple regression models is for predictive purposes. And that's the situation where after we develop a good fitting model, so we find that the predicted values coming out of the model are coming close to person's actual observed values on the outcome variable, as indicated by low residual values across all 100 of our participants, we have a good fitting model. We have a model that fits well with our data, the actual observed values on the outcome variable, in terms of the predicted values coming out of the model. Great. So then later, if we want to apply the model, when we apply it for prediction purposes, we're no longer going to have the actual observed values on the outcome variable. What we're going to have are the predicted values that come out of the model. But since we developed a good fitting model, we can have confidence now in those predicted values. When we apply the model to future samples of persons or groups of persons, let's say applicants or whatever the case may be, and now we're just working with the predicted values out of the model to predict persons' level of organizational commitment. We developed the good fitting model, so now we can have confidence in the predicted values coming out of the model. So those are the two purposes for which multiple regression models are used, for explanation purposes and for prediction purposes. But before you can use a multiple regression model for either purpose, you first have to build a good fitting model, a model that fits well with the data. Again, the data being those actual observed values on the outcome variable. And so that's always the first step. You need to have that good fitting model. You need to develop it. And then from there you can take that model and use it for explanation purposes or for prediction purposes. Okay, so here are the three core values of regression. We're talking about developing a model here. All the videos in the essence of regression, by the way, are concerned with developing models. The actual observed value in the outcome variable, the predicted value in the outcome variable coming from the model, and the residual value or the error in prediction. You understand those three core values and you understand the essence, and that's what we're all about here, is the essence of multiple regression, understanding multiple regression, and essentially what is involved and what we're seeking to achieve when we are developing a model, a good fitting model being our goal. All right, folks, you know the three core values, and you have a good one.